everyone, welcome back to my channel. Today we are going to start our second chapter, polynomials. So first, basically what are polynomials? Any expression which is in the form an x raised to n plus an minus 1 x raised to n minus 1 and so on is called a polynomial. Here you can simplify it like the power of variable, whatever variable is in the expression, the power should be a whole number, neither a integer means a negative number, it should not be a negative number, or it should not be a fraction also. So such expressions we can say that they are polynomial. Then what is zero of a polynomial? Zero of a polynomial means value of the variable of the expression given. It can be any real number. If we substitute it in the expression and we get the value as 0, then that number k is said to be 0 of polynomial px. Then we can categorize polynomials as linear, quadratic, cubic based on their degree. Degree basically means the highest power of the variable in the expression. If the highest power in the expression is 1, then it is said to be a linear polynomial. So its graph is a straight line, and you can see its example like px is ax plus b, like 2x plus 3 or like something like that. Next is quadratic polynomial. Quadratic polynomial means if any polynomial has degree 2, then it is quadratic. Px equal ax square plus bx plus c. This is the general form of quadratic equation, and its graph is a parabola. Parabola is U-shaped figure. If it is open upward, then a is greater than 0. A is coefficient of x square. And if it is downward open, then it means that a is negative, or coefficient of x square is negative number. So next is cubic polynomial. Any polynomial of degree 3 is cubic polynomial. Px equal ax cube plus bx square plus cx plus d. This type of polynomial, when we draw its graph, it intersects x-axis at 3 distinct points. So for cubic polynomial, the highest power of the variable should be 3. Next important topic is relationship between zeros and coefficients of a polynomial. So for quadratic polynomial, ax square plus bx plus c, if alpha and beta are zeros of that polynomial, then sum of zeros is equal to minus b upon a, where b is coefficient of x and a is coefficient of x square. Then alpha into beta, product of zeros is c upon a, where c is the constant and a is coefficient of x square. Next, cubic polynomial and relation between zeros of cubic polynomial and its coefficients. Since it is a cubic polynomial, it has 3 zeros, alpha, beta and gamma. As you see, alpha plus beta plus gamma, as sum of the zeros is minus b upon a, and alpha beta plus beta gamma plus alpha gamma is equal to c upon a, and product of zeros alpha beta gamma is minus d upon a, where a, b, c and d are coefficients of x cube, x square, x, and d is the constant. So next is our first exercise of this chapter, exercise 2.1. Here in the first question, the graph of y equal px is, we are given some graphs and we have to tell number of zeros of px. Since the variable is in x, the equation is in the x form, So we will see at how many points the graph is intersecting the x-axis. If the equation is if the equation was py, then we would have seen the y-axis, at how many points it is intersecting it. So for the first part, we can see that it is the graph is not intersecting x-axis at any point. So we can write this graph px shows that x has no zeros. Second part, it is clearly seen that the graph is intersecting x-axis at only one point. So we can say that this graph px has 1 0. Third part, here the graph is intersecting x-axis at three distinct points. So we can say this graph has 3 zeros. Fourth part, here the graph is in the shape of a parabola, which we just discussed. Here you can see the graph is intersecting the x-axis at two distinct points. So px has 2 zeros. Fifth part, in this graph, we can see that the graph is intersecting x-axis at four distinct points. So the graph px has 4 zeros. And the last part of this question, here we can clearly see the graph is intersecting x-axis at three distinct points. So the graph px has 3 zeros. So now we come to the end of this exercise 2.1. Thank you for watching. Stay tuned.